Thank you very much, guys, for coming to the talk. So this is just an information about me, okay? And I want to put a big disclaimer at the very beginning. I am not a computer scientist, okay? So take care or take with a grain of salt whatever I say about algorithms, mathematics, and so on. Excuse me. What we are going to see during the talk, we are going to talk about big data, which is big data. We are going to propose a simple model built on top of Liferay, and we are going to create an example, a real example built on top of Liferay, okay? And hopefully we will have some time for questions and hopefully answers. So, what is big data? Big data is just a buzzword. I mean, big data is nothing. I like to define it on this way. I mean, it's data which is so big that the regular tools, the popular tools that we are used to use, to solve the problems become extremely slow, really small, or too small, or really expensive. So they are no longer valid to solve our problems. So big data is actually how we use all the data that we already have to solve the problems we have. If you read books or hear to people like Gartner consultants, they define big data in base of the 3 V's, which are volume, velocity, and variety. The volume is not more than due to the internet, the IoT, and whatever, the number of transactions, the number of information is increasing really, really rapidly. Actually, Facebook has around 800 petabytes in Hadoop clusters, which is pretty huge information. The velocity is like the speed. Yeah, is the speed of the data. So Twitter, Facebook, whatever, they are constantly generating information. And we have tons of different information. Like we have numerical data, we have social media information, we have text, we have emails, we have video, we have like many different information of many different types. There are really popular usages in the real world, and I want to show you some examples. Maybe the most popular one of application of big data right now is recommender systems. I think, or I guess, all of you know the Amazon recommender system, where you buy a book, and at the bottom of the page, you get some recommendation of buying a new book based on your previous purchases. As all of you already know, it doesn't work really well. Netflix, for example, use this big data and machine learning to predict the future. So they monitor all the traffic within their servers, and they build analytic models, and they predict the scaling of the server. So they predict that in 2 hours we will have a peak. So previous the peak, we are spawning a bunch of servers, a bunch of clusters. Other companies are doing like churn models. They are preventing to their clients to move to another company because of some weird things. Sentiment analysis is very popular too, and how is people talking about some topic in the internet or about me? They are talking about me. Well, right. Real-time bidding is a really popular technology. When you go into a page, in some pages that are using this approach, under the hood, there are companies which are bidding for you to put the custom advertise. Healthcare, there are like many different use cases. And I want to show you during the talk how we can build an analytics platform based on that on top of Liferay. During the talk, I'm going to use this terminology, okay? I'm going to use the storage models. When I talk about the storage models, I'm going to talk about where I will store in the data, okay? And when I talk about computational models, I'm talking about how we process and transform all this data. And when I talk about analytics, I'm talking about which actions are we taking or we are going to take based on the previously computation models. So let's make a very quick round around the popular technologies. For data storage, I guess all of you already know Hadoop. Okay, Hadoop is no more like a distributed file system based on Java, and it's designed to be run in commodity hardware. It was copied from the original idea from Google, from GFS, Google File System, and is closely related to MapReduce, as we will see. This is the architecture. It's pretty simple. It has a main node, which is called the name node, which stores all the information for the whole cluster, and they have a bunch of data nodes where you replicate all the information. It depends on you if you replicate in 2, in 3, or 4 different machines. It's pretty easy. This is the most common approach to store the data. But I don't know, maybe during the last 6 years, maybe 5 years, a new movement started that is called the NoSQL movement, okay? And they have made different trade-offs. They are focused on completely different things. They are not focusing anymore in ACID. They are focusing on horizontal scalability. They are focusing on semi-structured data. So they have made a different trade-offs. And storing data in this kind of databases, like, I don't know, I guess all of you already know Cassandra, MongoDB, React, whatever. Maybe you are already using some of these. As they are very popular too because they try to to give you some horizontal scalability. There are a new movement, I don't know if you have already heard about that, which is called the new SQL. The new SQL was started maybe by, I don't know if VaultDB or maybe Google Spanner, okay? They are trying to create new ways of dealing with huge amount of data, but not in batch processes, but in real time. So they are trying to keep all the good things of the relational databases, like ACID transactions, like OLTP queries. So, but really, really, really fast. And the most exponents are VaultDB, which is an open source project, and Google Spanner, which is a proprietary implementation of Google. Let's talk about analytics. So we have all the data. We have all the data, and we have already stored it in somewhere like Hadoop or some NoSQL or new SQL database. Now we have to do some computations, an analytic model. We have to get some value of it. Hadoop is very related with a map-reduce paradigm. Okay, for those who are functional programmers, I guess you already know what it is. But it's basically a map-reduce where you have a map phase and then you have a reduce phase. Hadoop is the most popular technology on this field. It's very simple to use, but it has a really, really hard API to use. How it works is really simple. Let's suppose that you get a bunch of text files stored in a Hadoop file system, and you want to count how many times each word appears. Yes, you get the map phase, where you get every line in every file, and then you split and you count every word one time. And in the reduce phase, you get all the keys every time they appear. So if you see project appear 2 times. So in the reduce phase, you need to reduce, you need to zoom with the same key. The point is that using this API is very powerful to model some problems, but it's really hard to solve a completely different set of problems. So it's very hard to solve another kind of problems. So at the very beginning, it was thought for batch data model, for batch processing, and because the API was so hard to use, there many different projects were born, like cascading, scaling, Cascalog, just to solve the problem of the API usage. Another alternative for computation is Apache Storm. It's another open source project which focuses on real time. It's really easy. You can do whatever you want. You can do real-time analysis, online machine learning, whatever. And it has 2 concepts, which are the spots and the bolts. The spots are no more than the data, and the bolts are the processing that you can do with them, and you can combine whenever you want. This is another alternative. One more is Spark. We will see a few examples with this technology later, but it's an alternative to Hadoop. It runs on top of Hadoop clusters, on Hadoop HDFS clusters, and it has a high-level API, and you can use streaming, you can use SQL, you can use GraphX, so you can use many different approaches, but with a common API, so this is really powerful. One more approach, or one more technology that you can use to build your own analytics platform, it is Mahout, which is no more than a bunch of machine learning algorithms that you can use them to run on top of Hadoop or even in your regular Java project. They have I don't know, maybe hundreds of different machine learning implementations. At the very beginning, it was a crappy project, but I think in the last 3-4 years, they have improved a lot. And then if you want to move away from the Java world, you can use R. Okay, R is a statistical language focused on data visualization and machine learning. It's really the most powerful language for doing machine learning stuff, but it's pretty slow. If you move to a proprietary implementations of this kind of languages like MATLAB or maybe SAS, they are much faster, but actually R is a really powerful language, and you can connect to Hadoop too. So, and they are improving a lot. So I know this is a very quick overview of many different technologies, and what I want to do is to propose you an architecture of, let's choose a bunch of technologies and let's build analytic platforms on top of Liferay. And I want to propose that. I want to propose this architecture, which is pretty easy. We have a bunch of different sources of information. So we have information in our relational database. We do user tracking. We have system events. We have search data. We have logs. We have many different sources of information. Let's try to abstract everything. Let's try to put something in the middle where we can publish everything. Okay, so we can split the people who is working on the red side from the people who is handling the event broker. Okay, let's decouple them. And then I want to build the other side. Okay, I got the data, I publish it somewhere, I want to build some analytics on top of them. Okay, maybe I want to put on Hadoop to do some data crunching on batch mode. Maybe I want to do some real-time monitoring. Maybe I want to do some streaming and social graphing. So this is what I'm going to propose. So the data source, as I have already said, is the Liferay side. So in Liferay, we already have like many different information, like monitoring models, all the custom development you can do on top of Liferay. So you have many different sources of information, and you want to keep working on that. You don't want to work on the handling them. So we want to decouple that. So let's put in place an event broker. Okay, the piece in the middle, this one. So what I want to do is, as I've already said, I want to decouple. So I want to publish events there. And who is there? Who is this guy? This guy is no more than a distributed log. Okay? A distributed log is a really powerful abstraction for building data flow for building data flows where you have data here and you want to move data to a completely different place. And I want to propose to use Kafka. Okay? Kafka is an implementation on a publish-subscribe mechanism, but based in a commit log. Okay? It's a completely redesign of a publish-subscribe mechanism. If you are familiar with GMS or maybe RabbitMQ or something like this, they have followed a completely different approach. It's again open source. It was born in LinkedIn, but it became in open source in the Apache Foundation. It's fast, it's scalable, it's really nice. And the architecture is pretty much similar to those who are familiar with the publish-subscribe mechanisms. It's pretty much the same. I have some producer which puts some information in some topic, and the consumer can read from this topic and just consume these messages. But under the hood is based in a distributed commit log. Okay, so we have the storage. We have a storage all the information, whatever you want, and we have many different sources of information. So we have Liferay in this case. We have put something in the middle, which is in this case this distributed ML log, and let's try to do some analytics on top of that. Let's try to do this. Okay, so which are the problems I want to solve? I want to do some batch processing. I want to do some real-time processing too. Maybe I want to do some graph analysis. Is there any tool that I can use that provides me a unified programming model so I don't have to use like a bunch of completely different technologies with completely different paradigms, with completely different APIs? So is there any tool that provides me all this stuff in a unified programming model? And the answer is yes. The answer is Spark. Okay? We're going to see a very quick overview of many different technologies. Subcomponents of Spark. Spark is no more than a fast and general engine for cluster computing. So you can write your applications on Java, Scala, or Python, and just deploy to Spark, and they will be executed there. Okay. The point is that Spark can run on memory or on disk. If you run on memory, it's like 100 times faster than Hadoop. If you run it on disk, it's about 10 times faster. Okay. So Spark is has like a core project. Sorry, like a core project, and then it has like many different sub-projects, but all of them use the same concept, use the same concept of distributed data streams. So you can use SQL, you can do streaming using Spark, you can do some machine learning, or you can do graph analysis. Very quickly, I'm gonna take some water. The core of Spark is just based on which is called resilient distributed data sets. So basically you can get this abstraction and you can read this from a Hadoop cluster or any file system compatible with a Hadoop cluster. But even better, you can read that from a text file or even from a Scala collection. If you are a Scala programmer, you can get just you have a Scala collection and you can create a distributed data set, a resilient distributed data set from a Scala collection. It's pretty cool. Then we have SQL. SQL is no more than an abstraction where you can use regular SQL queries to query Spark distributed data sets. We have streaming, which is pretty much the same. We have windows of time, so on real time, okay, with quotes, you can do real time streaming, you can do processing on real time on these streams. And actually, you can get the streams out of the box on many different technologies, like Kafka, we will see how, Flume, Twitter, ZeroMQ, and you can define your own. For me, this is the most powerful one, which is the MLib, which is the machine learning implementation of many different algorithms. There are quite a few, and in every release they keep adding new algorithms. Basic statistics, regression models, linear models, decision trees, k-means, alternative least squares, dimensional analysis. It's really powerful. You can do graph, okay? So in case you want to build something like Google PageRank, you could use something like this. So this is like, I know it's like a very fast overview, but I want to show you a real example, okay, on how you can use these technologies to build that. I don't know, has any one of you read the blog post I did like a month ago? No, I don't think so. Okay, so let me show you. I will increase the font size right now. Okay. Yeah. So let me show you what I want to build. Okay. The first thing I want to do is we have Liferay installed, and I want to connect Liferay with this distributed event log. Okay, with this, in this case, with Kafka, and we want to store some information. Which information it is? It is. Let's suppose that every time we publish a message in the message board, a new topic, for example, I want to store this information. So every time I create a new message in the message board, I will store some message information in a topic, in a Kafka topic, okay? And then let's suppose that I want to collect some of them, I don't know, 10,000 or whatever. I want to create a model. I want to create an analytics model, and I want to do clustering. What does clustering mean? Clustering mean is based on these 10,000 blog posts, message boards, message entries I've collected, I want to do clustering. I want to divide all these elements into common groups. In this case, we are going to use the relevance of the words. So I want to do clustering. Yes, I want to, all these message boards, based on some analysis, based on the words and on the relevance of the words, they are very similar, and the other ones belong to the other one. And then what I want to do is to predict the future. So every time, in real time, I create a new message board, a new entry in the message boards, I want to predict, okay, this message is from this cluster, is from this type, okay? You can apply this to many different things, but I think this is really useful. So the first thing we have to do, or we need, is a bridge. Okay, this is in the reference. Sorry. I won't go deeper. So I need some piece that connects Liferay with Kafka. Okay, so every time I publish something, whatever, I just want to send to this message broker. I've written a bridge between the message bus and Kafka, so you don't need to learn a new API. You don't need to you don't need to learn anything new. You just need to publish a message using the message bus. And if you have this bridge deployed, which is an OCI bundle, it will automatically publish for you within the Kafka broker. Okay. So how do you use that? It's fairly easy. Let me open. Sorry, I think. See, here. So I have here. So this is a, okay. This is just for demo input pose. Please don't use the model listeners, okay? This is an advice. Take it for free. Okay? But every time I just publish this, again, this is an OCI service, okay? Every time, what I want to do is every time I publish a message, I want to store it, I want to send it to Kafka, okay? So what I have to do is just every time I create, I mean, a message is created, I just putting this information in Kafka. Sorry, in the message bus, which will end up in Kafka. Okay, as you know, just building a message and sending a message through the message bus, a known API for everybody. Sorry. Then we have already that. Okay. So every time a new message is created, I'm storing it in some, in this case, in Kafka. Then I have a completely different project, okay, which is the collector. What does it mean? This is written in Scala. I will increase. Okay, I will show you the good parts. And it's, I want to collect. I mean, every time I put all the messages in Kafka, I want to collect all of them to create my model. So what I'm doing is with an stream. I mean, like every 5 seconds in this case, if you see there, val ssc equals equal stream, blah blah. Every 5 seconds, I'm collecting all the stuff in the Kafka broker on this topic and just storing it. I'm just storing it in this case, on the message, on the temp folder. Okay, it's just here. Okay, just for the demo purposes. And then that's all. That's what it does. This program just collect messages. Okay, so you are constantly creating messages, and you can have something like this. So let's suppose. Sorry. Where is the? Yeah. Okay. Let me show you. Here. On every folder, every 5 seconds, I get all the messages I collected. Oh, sorry. Okay, so just all the messages I collected. Okay, so I have collected data. Let's suppose that we do that every night just to build our model. Then I want to build my model. Okay, I want to build my model. Here you can find some examples on how to use SQL on top of these files. Sorry, let me go. Okay, so here, this is the magic. This is the only thing I have to do. K-means, which is the algorithm, the clustering algorithm, train. So based on all the messages I've collected, I'm creating a model. I'm creating a K-means model, and I'm just storing it just in a dir, okay, whatever. And the last one, I think I won't have time to run it. If you want it, see running, look for me later. Okay. So what I've done, I've just started, I've created the model, and I want to predict the future. Every time a new message comes into the message boards, I want to predict which cluster, which group this new message belongs to. It's fairly easy. Sorry, this is. Okay, again, on real time, I'm just creating a stream, and I'm just listening for new messages to be published in this Kafka broker. And on each of them, I'm going to highlight this. Model.predict. What I'm doing is, okay, you are creating a new message. Let's suppose that created groups based on the language. Okay, so I magically can detect, okay, this message is written in Spanish, or this other message is written in, in English. When a new message comes in, I can say, this message belongs to this group because it's written in Spanish. But you can configure your this k-means algorithm. You need to build a bunch of vectors, but it's pretty easy to do, and you can predict the future. Okay, so I don't know if I have time to 5 minutes, so I think I can show you. So let's suppose, let me show you. Okay, let's suppose that I'm gonna. Okay, I have only one cluster node, okay, of Spark. Yes, for demoing. So I have like the collector, okay? I will increase the size now. Okay. So I'm just running the message collector I showed you before in the source code, okay? And I want to collect all these messages in the, I don't know, collect. Sorry. Okay. Encadir, collect. Sorry. So what I can do is, sorry. I can collect messages, okay? So I'm executing this streaming task. And what I'm going to do now is just insert a few of them, okay? I'm just inserting a few of them. Okay, I'm just inserting. Let me open new. Okay, I'm just collecting the message there. I could store these messages wherever I want. Then what I can to do is I can, sorry, it's here, okay. No, it's the other one, sorry. Okay, so I just insert the messages. Let me close that. Okay, these are the messages. These are the messages. Okay, I'm still collecting. Whatever is happening, I'm writing into the, so I can stop collecting. So what can I do right now is to train, to create my model. Okay, so I want to, I think I call it collect live, and I want to store the model in collect live. Okay. Train. Okay, this one. So I only store 468, which is ridiculous. Okay, but as you know, I've created my model and I've shown you some of the clusters. Then I just can reuse this model, and if you go here, I'm finishing now. Sorry, collect live. This model. Okay, this is the model. Okay, this is not, it's in binary format. Okay, it's not us. And then the model will read these files every time I put something, and will do the magic to predict the future. So I think I don't have more time. Sorry. If you want to see the prediction part, or if you want to go deeper in some part, you just come to talk to me and we can see it deeper. Good. Thank you very much.